Welcome back to the workshop. We want to continue taking a look at section 3.6, which is on marginal distributions. And in this video, we'd like to consider two discrete random variables. Of course, we can actually talk about more than just two discrete random variables, but it looks a little bit different depending on how exactly you're restricting things. So for now, just two discrete random variables and their marginal distributions. All right, if x and y are discrete random variables, and this is the value of their joint probability distribution, then the function given by g of x, which we'll say is the sum over all possible y values of f of x comma y. For each x in the range of x, is called the marginal distribution of x, right? So every value that the random variable might take on. Correspondingly, we have h of y is the sum over all x values of f of x comma y. So when I sum over all of the y values, that removes y from the function f of x comma y. And when I sum over all of the x values, that's going to remove the variable x from the function f of x comma y. So the result is just a function in the variable x, or just a function in the variable y. So in the first case, it's the marginal distribution of x. In the second case, it's the marginal distribution of y. So in the previous section, we took a look at selecting two texts from a shelf, where we have two programming texts, one inorganic chemistry text, and three calculus texts. X, let's see, the random variable x is the number of programming texts, and the random variable y is the number of calculus texts. And we found that the probability of choosing 0 of either one of these things is 0, or you can put a dash through that spot. Similarly, for choosing two programming and one calc, or two calc and one programming, or two calc and two programming. So this was our joint probability distribution. And we know from our previous example that we can find these marginal distributions just by adding up the rows and adding up the columns. But what I'd like to do is I'd like to focus on what it looks like from the definition, okay? Adding it up summing over all x values or summing over all y values. So let's see here. We can go with, let's do g of x first. So g of x is the sum over all y values of f of x comma y. So what does that look like? Well, in this case, y is the number of calculus texts, and that could be 0, 1, or 2. So this is f of x comma 0 plus f of x comma 1 plus f of x comma 2. And the result is a function just in x. Okay, but the thing is we don't have a nice expression for the function f. We simply have values assigned to each possible input. Those values are assigned using this table. Okay, so we don't have an expression for the function f. We have a table of values for the function f. And so we have to do the same sort of thing for this particular example. And essentially it works out to be just, we can give it piecewise. Because there's only 3 inputs, so we can do that. That's not a problem. So if we want to look at for x equal to 0, because x can take on the values 0, 1, or 2 as well. And when I look at 0, 0, that's just 0. When I look at 0, 1, 0, 1, that's 2/15. And then 0, 2 is 1/15. So f of 0, 0 was 0, f of 0, 1 was 2/15, and f of 0, 2 was 1/15, which of course is just 3/15. And then we have for x equal to 1, we would have f of 1, 0, f of 1, 0, f of 1, 1, and f of 1, 2. So 3, 6, and 0/15. 3, 6, and 0 gives us 9/15. And then finally, for x equal to 2, we would get, let's see here, x equal to 2 with y equal to 0. So f of 2, 0, f of 2, 1, f of 2, 2. So 3, 0, 0. So this is the distribution of x, the marginal distribution, 3, 9, and 3/15. Which if we wanted to, we could have observed that here as well. 2 plus 1 is 3, 3 plus 6 is 9, 3/15. Okay, so that's our marginal distribution of x. And we can do the same thing for y. Find the marginal distribution of y, which would be the sum over all x values of f of x comma y, which would be f of 0 comma y plus f of 1 comma y plus f of 2 comma y. But of course, it's still not in a nice expression. It's going to be the individual values. So there are 3 possible values for y. So we simply give it as like a piecewise defined function. So 0, 0 is again 0. 1, 0 is f of 1, 0 is 3/15. F of 2, 0 is 3/15. So 0 plus 3/15 plus 3/15 is equal to 6/15. And that's for y equal to 0. And next we want for y equal to 1. So we go along here, f of 0, 1, 1, 1, 2, 1. So 2/15, 6/15, and 0. Is 8/15. And then for y equal to 2, we would get f of 0, 2 plus f of 1, 2 plus f of 2, 2. So this is the marginal distribution of y. And of course, again, we could see that in the table as well. 3 plus 3 is 6. 2 plus 6 is 8. And 1 plus 0 is 1. So that is the marginal distribution of x and the marginal distribution of y. Notice here that the labels for that column and that row have been given appropriately, okay, identifying the marginal distributions. So if you want to show your work as a table, that would be okay with me. That's not a big deal. But you should also understand this as well, because it's not always necessary to give your work as a table. You might actually be given your distribution, your joint probability distribution as a function with, you know, some function of x and y instead of just a table of values. And in such cases, this might be a little bit more, understanding this might be a little bit more useful, a little bit quicker, a little bit easier. But that's all that I have for that example. So next we'll move on to 2 continuous random variables and taking a look at their marginal distributions. And then beyond that, we will look at 3 or more discrete or continuous random variables. So I'll see you guys back in the workshop very shortly.